So here we are at Regal Creek, and Regal Creek is just down here. So that's Regal Creek, laid bare here in central Texas. No water even to obscure our view of the ancient's concrete. Interesting. So we can see the concrete very clearly. The first thing we see is this diagonal. There's the flow of the river, or the flow of the creek. And you can see this diagonal construction, right? 45 to the flow of the river. More diagonal, although that looks like a loose stone, but loose piece of concrete, we should really call it. It's not a stone. It's not a natural geological stone. Okay, so we have the, quote, bedrock layer. It's not really bedrock, it's concrete. And the next layer up, we see this immediately diagonal construction. See that point right there? It's pointing across the creek. So that's right angle to the flow of the creek. And we'll always see these pointers. Here's another pointer. So diagonal construction, right? Diagonal construction. Diagonal construction. There's the flow of the creek. Here's the diagonal. We found this all over the world. Let's keep moving. Oh, and here's an opposite diagonal. There's the point. 45 to the flow of the creek. So you can see that 45. There's no doubting it. There it is. And when we get on top, we see how perfect it is to the flow of the creek. Now it's curving to the right a little, right? And there's another diagonal. It widens out and it steps down about 8 or 9 feet. So that's how they did it. They stepped it. That's how they did all the hills in Texas. They stepped the hills. It's not like, oh, it's sedimentary layers that are breaking out. Yeah, it's a dramatic step down. Wow, it really goes down. You can see how steep it is. This little creek that was barely big enough to get a name was built in ancient times as the foundation of hills on either side of it. Who built it? Geologists are told that we are the first advanced race in the universe. This is what they, and we, and everyone is told by the scientists. Who controls the information the scientists get? Well, you can find that out. Who writes the textbooks? So, if we are the first advanced race in the universe, and this is what NASA says on its website, I'll insert a screenshot of their website. It says it right there. It says life has not been found on any other planet or moon or anywhere else. So, as far as science is concerned, science. Homo sapiens sapiens is the first advanced race. If we are the first advanced race, and this is what's going on in the mind of every geologist and every geology student as they engage the terrain of Terra. Yes, it is Terra. Tir. T-I-R, Welsh. Tir, Terra, terrain, terrestrial, extraterrestrial. Our planet's name is not Earth, that's soil. So we don't even know the name of our own planet. So as the geology students and the geology professors go out onto the land, they are thinking the land must be natural. It must have come into existence through natural forces, right? Because being the first advanced race in the universe, there has been no other advanced race in existence to build the terrain. We know we didn't build it. Homo sapiens sapiens didn't build the topography that we see, right? Hills, mountains, valleys, creek beds, riverbeds. So if we didn't build it, the logic goes, in the mind of the geology professor and geology student, then it must, the features of our planet must have come into existence by natural forces. So that's the premise. That's the false premise that keeps geologists and geology students and everyone else, from seeing the construction. No one's looking for diagonal construction of creek beds and riverbeds. Why would they? It just happened. It just formed. It formed. It folded. Yes, and there was uplift, and they have all these terms. Joint fractures. The term joint fracture, joint-fracture, is gaslighting on the face of it. There's no such thing as a joint fracture. If you ask a carpenter to produce a joint fracture, he'd say, what are you talking about? You mean a joint? These fractures break apart. Joints hold together, right? Same thing in geology. Geology, it's not really geology, it's ancient construction, it's terraforming, it's conscious construction, the features of our planet. So joint fracture is the controllers, the dark controllers' way. I won't name the families because you can find that out very easily. That's their way, that term and all the other terms in geology are their way of keeping us from seeing the obvious. What is the obvious? That all those vertical lines that go through multiple layers of sedimentary material, those lines are believed by graduates of controlled universities to be joint fractures. But wouldn't you just ask the professor, if you hadn't been controlled already, if your mind hadn't already been subjected to mind control, which is the universities and high school, wouldn't you just ask the professor, how is it a joint fracture if it's held together over the eons? If it's a fracture, it's breaking apart. But these are seams, like seams in a garment. These vertical lines that bisect many different layers of material join the sections together. So what the ancients did is they worked section by section across the planet. Vertical line, vertical line, vertical line. Sometimes their sections are 8 inches wide. Sometimes they're 80 feet or 80 meters or 80 yards or 80 meters wide. That's one of the clues. That's one of the really excellent clues that we have if our eyes are open, which means if our minds are open. We have to be able to notice these things. We have to be able to ask the question, is it natural or is it artificial? If you don't ask the question, is it natural or artificial, your premise is already skewed, it's already corrupted everything you find from there, because you'll always find it to be natural. Just ask the question, and then we can perform science. Maybe it's natural, maybe it's artificial. So let's continue the walk down Regal Creek in central Texas. We're here to diagnose the terraforming of the ancients, and we see signs of their terraforming everywhere. We're going to walk toward the water and see what's happening. There's not much water left because it's been a dry summer. One of the first things we notice is vertical seams through this material. You always find the vertical seams. You say, seams? That's just a fracture, is it? Is that a fracture? Is that breaking apart? Or is that joining together? Now some seams do break apart. Here's 2 sections that were joined by a smaller section. Here's the smaller section, and then we have the breaking out of the smaller section. This seam here joins this seam, which joins this seam. And notice, again, it's not a crack or a fracture, it's joining together. Now we also notice across the way endless vertical seam construction, right? So there you have the vertical sections. Then, moving left, we see the same vertical seams, always the same. We're walking toward the, quote, limestone. All of this is supposed to be limestone, but this is more obviously what the geologists call limestone. So let's look at the beautiful limestone, the natural limestone. Well, it looks natural. Why would anyone say that this is artificial? I mean, that's madness. It's all modeled on top, right? It looks like totally natural material. My gosh. The beautiful texturing here, it's got to be natural. Just wave action, water action, rippling, right? That's what the geologists will say. Say it's rippling, it's water rippling. It causes waves. It's a wonderful theory. The entire theory of geology, it is a theory, is a wonderful theory. I love it. It's fantastic. They did the best that they could under the false premise that they held. What is that false premise? That we are the first advanced race in the universe. The first advanced race to raise its head above the muck and mire. Here we are. We know we didn't build this. So, since there's no other race out there that could have built it, it's not built. It's all natural. It must have come about. All these geological features must have come about by natural forces. So that's the premise that is held when geologists go out onto the land. And that's why the question that is never asked by a geologist is the following question: is this natural or artificial? That never occurs to a geologist or a geology student or anyone else who's undergone the education system. Is this natural or artificial? That question never occurs. It must be natural. Must. How do we diagnose this? How do we know that this is, in fact, artificial? Well, we have regular lines that are vertical, not perfectly right angle, going through what is meant to be sedimentary material. And this line, this seam, goes through that layer too. But there are many layers here. There's one layer, there's the, So this line goes through all those layers. It's impossible. Now this is interesting, right? Another crack, according to geology, fracture. It's called a joint fracture. Well, joint fracture, joint-fracture, that's a main term in geology. That's to label every single vertical line that goes through sedimentary material. Does that look to you like it's fracturing apart? If it was fracturing apart, wouldn't the section on the left be falling away? But it's joined strongly, you see? See how strongly it's joined? So that is in fact a seam, like a seam in a garment. I'm going to show you something else that's very interesting. Let's see. This, quote, sedimentary material doesn't want to go very flat, does it? Sedimentary material is flat for reasons that do not have to be gone into. This isn't flat. This isn't horizontal to the pull of Earth's gravity. Then, when this actually non-sedimentary concrete, artificial concrete, gets there, we got another vertical line that goes through many different, quote, time periods. It's not time periods, it's just they laid this section down, then they laid this section down. And then they said, okay, we got all these layers, which don't necessarily match the layers on the right, but that's because it's concrete. It's not sedimentary layering. They laid that smaller section down, then they laid this section down. And they said, we're not going to have any layers there. It's just going to be no layers. That's what they said for that section. But it's really, there are a few layers underneath the facing concrete. So, what else? I mean, it cannot be more obvious. Here we have 1, 2, 3, 4, 5, 6, 7. At least 7 layers, okay, of, quote, sedimentary material. And there's one line that bisects all those layers. See that line? Wonder how nature did that. Another vertical line. Here's another vertical line. Goes through many layers, quote, of sedimentary material, unquote. You see the two major time periods, how thick those are. And then we see the smaller, quote, time periods in the horizontal layers, right? At least 2 time periods, 3, 4, let's say. And then you've got, one line zipping through all of them. Impossible for nature to do. There are much more obvious sites. In other words, There are sites that show the artificiality, the building, the construction much more obviously. But once you've seen those, then you can begin to see what they're doing. They weren't precious about their okay, so same thing. Line that goes through many, many, many different layers, okay? And so what the ancients did was they laid layer cakes in sections. So they laid the section on the right, so we have the line on the left, right? That's the section break. It's a seam. So on the right we have this section that was laid in a layer cake of at least two. There's one up there, one down here, 2 layers. And then maybe some other layers, hard to tell. And that's a layer cake, at least two layers, right? There's your cake. And then they went to the right, or they went to the left. And they laid this layer cake of however many layers they wanted it to be. Now remember, different sized and different shaped sections give us stronger building, which we learned in the pyramids on the Giza Plateau and in Bosnia. There's not one single stone that's like any other stone. And in all of the pyramids and tumuli and hills of the Bosnian pyramid complex so far, no one's found one baked clay construction stone that's similar to any other. They're all artificial stones, so there's no molds. The ancients didn't use molds because they didn't want to make their structures out of similar size and similar shaped stones. They knew that was weak building. That's exactly what we do. We make the weakest building there is. All of our stones are the same shape and size, so it's a problem. Also in the Bosnian pyramids, all of the stones are inclined into the center of the structure. No matter which face of the structure you're facing, they're weighted down into the center of the structure, so you can basically see under them more than you would if you were looking at construction stones that we made, which would be perfectly horizontal. Let's zoom in on that construction. I mean, nothing could be more obvious once you know that the question may be asked, you know? Once you know the question, and once you've seen the clearest examples of artificial ancient construction, then you begin to notice. I knew that the Pedernales River was artificial because I'd seen a video that showed the diagonal construction. It's all diagonal construction, so obvious from above. So I knew it was artificial, but the ancients seemed to have variations on the theme. So just because it's artificial doesn't mean it's exactly like some other river. It's got similarities to the building, just like pyramids across the planet have similarities to their building. The lowest layer laid down by the ancients has very few seams, okay? Very few section seams. It's got to be the strongest. And then above, you've got sections, 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 sections. My theory is that this is ecological terraforming. These smaller sections above are meant to break out, to erode, to create potent mineral-rich soil, to feed vegetation across the land. That's what ecological terraforming is. So you've got the base layer that gives you the structure of the river, which way it's going and everything like that. And then you've got the layers above that very, very slowly come out. The seams are strong, but the sections will come out at the seams. So you'll have full sections, no cracks, no fractures, totally integral, totally strong, totally durable, each section is. But then they will come out at the seams and just break out as massive blocks and then slowly get chipped away. I would propose that all of this texturing and modeling is virtually the same as how the ancients built it. They wanted a series of angled features here because they knew there was going to be a lot of water coming through, and they wanted to break the water with these angled features that are facing upstream. And then they wanted to channel the water, so they had these channels. Except for the minorest erosion over the millennia. We don't know how long ago the ancients built this, but this is exactly how they wanted it to be, right here. That's what I would propose, and I've mentioned this in other videos, where there's very interesting features in a little creek called Rock Creek in California. And geologists would say that's erosion. Well, erosion is just a catch term to mean it happened. It just happened that way. It just happened. Well, erosion doesn't produce all the many hundreds of features we see across the land, because no matter what the feature is, they'll say it's erosion. If it's a 400-foot tall spire, they'll say erosion. All the land was eroded around that spire and left this tall structure. If it's a big hole, they'll say erosion. So if you go down into the earth and you have a hole, you go up and have a 400-foot tall spire, they'll say erosion. No matter what it is, a wave, a smoothness, a roughness, a mottledness, they'll say water seeped in and made it mottled, or water smoothed it and made it smooth, you see? So no matter what the feature is, they say erosion. Erosion over time, water, wind, sand, grit. We could also zoom in on that straight line seam over there that goes through the, quote, sedimentary material, right? Vertical straight line seam, interesting. And here's one here. Vertical. Doesn't mean it has to be right angle, right?